In this lesson, I am going to show you guys how to use properties of log. We are going to use the properties of logs to expand and condense the log expressions. The first one is the product property. So log of a product is the same as the sum of the logs. The second property is the quotient property, which is similar to the product property. Log of a quotient, so quotient is the y, as you can see, m over n, that's the given quotient. It's the same as the difference of logs. And then the last property is the power property. So log of a power, so with the power property, so log of a power, the exponent comes down here and it becomes the coefficient. So here you have n times log base b of m. Now we are going to look at condensing logs. Condensing logs is rewrite as a single log. Simplify if possible. Let's take a look at the first example of condensing log. So here we have 4 times log base 4 of a plus 2 times log base 4 of b. Okay, so condensing log is to rewrite as a single log. Now condensing, okay, is to go from the right hand side of the properties to the left hand side of the properties. This is what it looks like on the right hand side of the property. We're going to use the log properties to condense this. Okay, so the first thing we have to do here is to use the power property to get the coefficient up here to the exponent. Okay, so it's going to look like this now. Log base 4 of a to the 4th power plus log base 4 of b squared. That was using the power property. So now we're down to this. This is sum because it's add. So the sum of logs is the log of the product using the product property. Okay, so this would be log base 4. The product is going to be a to the 4th power times b squared. Okay, so it'll be a to the 4th power times b squared. So that is condensing. We go from expressions with more than one logs down to an expression with just a single log. Okay, so let's take a look at the next one. So here I have log base 2 of 15 plus log base 2 of 4, take away log base 2 of 6. We are going to condense this, so turn this into a single log. Okay, so the first thing here is going to be these two. Okay, so you got sum of logs. Well, sum of logs is the same as the log of the product. So it'll be log base 2 of 15 times 4, right? You got 15 times 4. And then minus log base 2 of 6. So now you have takeaway. Okay, so it's the difference of logs. So the difference of logs is the same as log of a quotient. So this would be log base 2. So you got 15 times 4 up top. And then all over 6. Okay, and then you can rewrite this as log base 2 with 15 times 4. That is going to give you 60. And then over 6. And then this turns into log base 2 of 10. Okay, and then we're not going to evaluate this. We could if we wanted to. Okay, so let's take a look at the next one. So the next one you have 1 over 3 multiply with log base 5 of 8 plus log base 5 of 27 minus log base 5 of 3. We are going to condense this expression, so turn it into a single log. First thing we have to do is distribute the 1 over 3 to get rid of the parenthesis. So you have 1 over 3 log base 5 of 8 plus 1 over 3 log base 5 of 27 and then minus log base 5 of 3. Okay, and then we would have to use the power property, okay, to get the exponent up here. Same thing over here, the exponent would be here. So 1/3 is the same as cube root if you want to change it to cube root, but we're just gonna keep it as 1/3. Okay, so here would be log base 5 of 8 to the 1/3. Okay, and then plus log base 5 of 27 to the 1/3. And then minus log base 5 of 3. So here the sum of the logs is the log of the product. So this would be log base 5 of 8 to the 1/3 times 27 to the 1/3. Okay, and then minus log base 5 of 3. I'm going to simplify this before we move on to condensing it. Okay, so this is an easy one because you got log base 5. Now 8 to the 1/3 is the same as cube root of 8. So cube root of 8 is going to be 2. And then here cube root of 27. Cube root of 27 is going to be 3. And then minus log base 5 of 3. Okay, so here you got 2 times 3. That's going to give you 6. So log base 5 of 6. Take away log base 5 of 3. And then here you have the difference of logs. So the difference of log is the same as log of quotients. So it'll be log base 5 of 6 over 3. And that is going to give you log base 5 of 2. Okay, so all that is the same as log base 5 of 2. Let's take a look at another one. So here we have 2 times log 6 minus, now this log has no base. Okay, so we understand it's base 10 when there is no base. And here you got minus 1 over 4 log 16 plus log 3. Okay, so we are going to condense this log expression to a single log. So we have to use the log properties to do that. Okay, so the first one we are going to apply the power property because the 2 is the coefficient. And we need to get that coefficients up here to be an exponent. So it's going to be log, okay, 6 square, take away, same thing here, we're going to use the power property. So this would be log 16 to the 1 over 4 plus log 3. So here I'm going to clean this up a little bit before we continue to use the properties of logs. So here I got log 36 minus log. Now 1 over 4 is the same as 4th root. So when you take 4th root of 16, you get 2 because 2 times 2 times 2 times 2 is 16. And then log 3. Okay, so now we would have to apply the quotient property here. Okay, so that is going to be log, okay, 36 over 2. Okay, that's going to give us 18. And then plus log 3. Okay, so log of 36 over 2 is going to be 18 plus log 3. Okay, so now we would have to apply the product property. So that is going to give you log 54. Okay, so this is log base 10 of 54. And you can evaluate this easily, okay, because it's base 10. You can input this into the calculator. So if you punch in log 54, it's going to tell you what it is. Okay, so now we're going to take a look at expanding logs. So expanding log is to go from one log to more than one logs. Okay, so let's take a look at the first example. Okay, so here we have log base 4 of a to the 9 power all over b. So this is what you see on the left hand side of the equal sign of the property, and you have to take it to what's on the right hand side of the equal sign of the properties. So here you have log base 4. Okay, so you have log of a quotient. So this is a quotient, it's divide. So that is the same thing as the difference of logs. So it's going to look like this now. Log base 4 of a to the 9 power minus, that's the difference, log base 4 of b. Okay, so continue here. So for this term right here, you have to apply the power property to bring the 9 down to the coefficient. So you're going to have 9 log 4 of a minus log 4 of b. Okay, so this is your answer. So the next example, we have log base 2 of y over z to the 5th power, and that whole thing square. Okay, so we are going to expand this using the properties of logs. Okay, so the first property we have to apply here is the power property. Okay, because we got to bring down the exponent here to the coefficient. So you have 2 log base 2 of y all over z to the 5th power. So we apply the power property to bring down the exponent as the coefficient. So this is multiplied. So now we are going to apply the quotient property. Okay, so log of a quotient is the same as the difference of logs. So here you're going to have 2 times log base 2 of y minus log base 2 of z to the 5th power. Okay, and then you got 2 times log base 2 of y, and then apply the power property here. So we bring down the exponent to the coefficient. So it'll be 5 log base 2 of z. Okay, so now I'm going to multiply the 2 to get rid of the parenthesis. So it'll be 2 log base 2 of y here minus 10 log base 2 of z. So this right here is your final answer. So we went from the left hand side of the equal sign to the right hand side of the equal sign. So that is expanding. Okay, so we're making it bigger, going from 1 log to more than 1 logs. Okay, so let's take a look at another one. So here I have log base 3 of 4th root to the 5th power times n squared. Okay, and then I have to expand this using the properties of logs. Okay, so the first thing I'm going to do here is to rewrite fourth root in terms of exponent, right? So this is the same as log base 3 of to the 5th power n square, and that whole thing to the 1/4. Fourth root is the same as 1/4. And then to expand this, first thing I have to do is bring down the exponent to the coefficient using the power property. Okay, so here I have 1/4 times log base 3 of to the 5th power n square, and then 1/4. So here the log of the product is the same as the sum of logs. So I can rewrite this as log base 3 of to the 5th power plus log base 3 of n square. So now I would have to apply the power property for this log and the power property for this log. So that is to bring down the exponent. So 1/4, so this would be 5 log base 3 of plus 2 log base 3 of n. Okay, and then distribute the 1/4. I end up getting the 5/4 here. Log base 3 of plus. Now here you're going to have 2/4, right, when you multiply. So 2/4 is the same as 1/2. So it'll be 1/2 log base 3 of n. Okay, and there you have it. This is your final answer. So that is expanding log, where you go from the expressions with one log to an expressions with many logs using the properties of logs.